Alright, we're back. So, now I'm going to play with airplane stuff. So, we're going to see is that cylinder going to fit this better than that case over there. I still think I need to get the early Evo case 4-speed bike, which is the 86 to 90 case. I think that's the one I want to use, but I don't know yet. So, all of the stuff is the same locations, the cam locations relative to crank. All the Sportsters are the same. From 1932 to current to 2020, I think was the last year of a Sportster. All that stuff's the same. So the difference on this is that your push rod locations are down here. Okay, I got to get this lined up better. Okay, this is taller deck motor, so I got to get it more where it's going to sit. Okay, so these are going to be about, I don't know if it's a ½ inch difference. I'm thinking more it's closer to 7/16, around 400 thou, but I'm not sure. So this has a taller deck height than this motor. So right now I just want to see if these are the same relationship. So take our scale and our caliper here. So the first thing you do is you make sure this is going the same dimension, same angles. So this needs to go forward a little bit because this is not quite the same. So a little bump, bump, bump. Drop it down a little bit to where these angles are the same. So it's a little bit too much down. Now this back one's a little high. Too low. Okay, we're pretty close now. Okay, so what I want to know is, so you have a different lifter offset because these cams are on center. These lifters are on center with the cam lobe. These ones here are offset. And the offset is the front one goes, the exhaust, which is here, goes to the outside, and the intake goes this way, so it spreads the lifters apart. See, these are closer together than these. Now the difference in the dimension is, take your caliper and measure it. Okay, this one here is roughly 1.8 inches, give or take a little bit. Okay, now you do the same thing over here. Look how far off we are. We're not even close. So this one's going to be probably over 2. Okay, that looks semi-close to center. 2.250, so we're 2 1/4 inches. I can also take a 6-inch scale and do the same measurement. So you can see how we're around 1 3/4 inches, roughly. And this one over here, if you do the same thing over here, we're roughly 2 1/4 inches. See? So the next thing you check is the drop test. Is where is this one relative to that one? And if you look at it, you notice how the front one, it looks like it's in the same spot. Now I know it can't be because I know it's offset on the top one. It's just, I can see it's a little different, but so you can see a little bit of offset change there. So I'm not sure if I'm showing out the camera, but on this one over here, you can see how far off we're here. It's way off this one. See, not even close because it adds up. Okay, so it looks like these are close to being on center, but you know, it's the offset is in there. So why is this important? Because I want to do something different. So that airplane cylinder over there, I want to make a 4-cam motor out of it. So if you take this one here, and we have push rods right here. See how it goes down? Now if we take a rough dimension of what this needs to be, we are roughly 2 1/8 inches. Now is that spreading or is it going straight? We don't know. So then we go over here to the bottom and we do our same dimension right here. And this one here looks pretty close. So we're right there. We're about 2 3/16. Well, we're not quite there. A little over. We want to be. Trying to get a place where I can see more centered. Yeah, we're definitely more than 2 1/8. So I'm about 2 3/16. Oh, we're at 2 1/4 almost again. Okay, let's actually take the scale, which is a little bit easier to see this kind of stuff in. So you go center the hole there, center the hole here. It's definitely not 2 1/4. It looks like it's 2 3/16, so it's 2.2 inches here. And up in here, it's definitely lower. So that means these push rods are going closer together by the time it's way down here. But in my application, I don't really care about that. If I had something that was this diameter sitting in here, like a socket, I could probably see a difference in dimension just by sitting in the hole. So it's just under 1 inch in diameter. Let's see what we got in the sockets here. They're roughly about 1 inch. That's too big, I think. Yeah, way too big. How about that one? Oh, that is so close, but not yet. So what do we got in sockets that we can use? 13/16 maybe? No, that was one that was close. Oh no, that's a 3/4. That's a 13 right there. So 11/16 is probably too much, but it's close. Oh, that's just pretty flat. See, it's good and flat in there, so it gives me an accurate number. So now I need another 5/8 socket that's deep. So that'd be one of these over here probably. 9/16, that makes this a 5/8. Too much angle on that. So stand this up a little bit more. This one's too small in diameter. Oh yeah, big difference. And this one's probably too big. Oh, it's undercut, so it might fit. Oh, perfect. There you go. It's made for it. Okay, now you look at it. So if I look at it, they look like they're splayed out, not splayed in. Which is perfect for me because that makes it bigger, because that's 2 1/4 inch. So we gotta measure this between here and here and see if there's a difference. You can also measure the outside too and give you the same dimension. Try not to touch it here. They're the same. So they're straight. So these are going straight. So it's linear straight. You would think an airplane would be straight. It is. Okay, so. And once again, our hole over here should be about 2,250. And it's a little bit less. Well, not exactly centered over here. Kind of center things up a little bit. Yeah, it's definitely like that 2 3/16, 2.2 inches. So if you turn your scale this direction, you read 2.2. Looks pretty close. And this is 2 1/4, but this is way under. This is 1 3/4. So this case here is no good. This case here is pretty close. But we can see how the Evo case is higher than the Ironhead case. And it also has the oil pan built scraper down here at the bottom I like. Down in here. All that extra dimension down there. So that means if I go to the 4-speed Sportster case Evo, which is 86 to 90, 4-speed case, which means it looks like this. I think that's the one I'm looking for. So I need a junk one of those cases with a blown up tranny if anybody has one laying around. I need the right side. I don't care about the left. The 5-speed Evo bike has the same on-center cams as this late model. So it's going to have these real narrow center lines, which is not going to help me. So I cannot use 5-speed Evo stuff, which is your 90 to 03. This is 04 and later. So I'm either going to have to use an Ironhead case, or I'm going to have to use that early Evo case. Now the early Evo case has a big fat lifter block that goes through here, and the oil holes are a little bit different. I would like to retain these piston squirters that are in this case, so I'm going to have to figure out how they did that. And I'm going to try to put those squirters inside of that case to lubricate the pistons here, because these are really big bores here. We need some oil up in here. So I think that's the direction I'm heading. So I had one case I saw on eBay, I just don't want to pin the money for it. I'm spending lots of money for junk I'll never use, so this case is junk, I ain't using it. This case here is sort of junk. The other case that's in the box over there, that broken one, it is junk. But you have to buy all this junk parts to figure out what works and doesn't work. It's called mock-up. So that's how you find out what happens. So basically it looks like we're going back to this kind of a bolt pattern because it lines up the best with our lifters down here. And that is a very important thing to have working correctly. Now, when I used the big twin case, which is in that box, that Evo case, it's the same as the shovel head. The lifters are over here, and they're offset way forward. See, the cylinders is on center through here, but this is the center line of your cylinders right here. And see, the lifter block's way forward. Same here. So it makes it worse. When you go to the 4-cam motor, it's a lot less problems. Now, even though that case in there, that top end will bolt right onto it, I can bolt that right on that Evo 140 case, but the push rods are going to be really, really bad angling. Now, we can make that work because it'll obviously work for Harley. It would work. The big difference is the camshaft. The rear cylinder is the correct location for your ports and stuff, the push rods. See, these cylinders are the same. They're all the same, front and back, identical. So, we have the exhaust here, intake over there. So obviously when you have the other cylinder, like that, ooh, there's another one. See, we have exhaust, intake, exhaust, intake. Harley has exhaust, intake, intake, exhaust. So this cam is correct, these cams are wrong. So when you go to a single cam motor or a dual cam motor, if you use a twin cam case, you can have the same problem. The rear cylinder cam is correct, this one is reversed. You have to reverse the cam lobes. So the exhaust lobe needs to be on this one and the intake on this one to work. So getting a custom made cam is going to be probably a $1,000 bill. Yeah, probably. And be prepared to wait about 6 months or a year to get it. So if we go this route down here, I can actually take the cams and reverse the lobes on the cams on a Sportster because you got individual lobes. So when you buy racing lobes from Redshift, the lobes are pressed onto the stock cam. They take the stock camshaft, they grind the lobe off, make it round. They push a lobe on it, you put it where you want it, you weld it on. So in this case here, I'll take the lobes that are here, I'll reverse the intake to exhaust lobe, and I'll push them onto the cam, make sure they're rotated the correct direction for the offset, and then weld them where I want them, and I'm done. And it doesn't cost any extra money to do that than a stock cam, because you're going to pay about $500 for a set of lobes anyway, so there's no difference. So, and there's no waiting. So that makes it a little easier. So even though it's a lot more work to make the case work, you got better push rod alignment and you got access to a camshaft. That part's good. The transmission, I don't care what you do, any transmission you put behind a big ass motor is going to blow up. That bike there, 500cc, breaks trannies every now and then. My big bike motor, which is a 95-inch, 90-inch, depending on what year it was, it blows transmissions every time you're on the bike about. It blows the case apart. It does this kind of crap. It likes to separate gear teeth off the shaft, especially on the low gear. It likes taking all those teeth on there and loses them. And when it does that, it likes to ventilate this thing downwards. So that will happen twice a year on that bike. It gets expensive. So these transmissions have to go bye-bye. And the big twin trannies aren't going to take it either, because the M8 trannies blow up just like everything else. And there's one of those floating around down there somewhere. Yeah, there's one down there. It's a twin cam or an M8 6-speed. Piece of crap. Third gears, the teeth like to come right off them, so they're garbage.